All right, in this video here, we are going to talk about inverse trig functions and how we can use them to solve for angles of triangles and solve word problems that can be modeled using right triangles. All right, so we're asked to find the angle theta, and I didn't write this up here, but we want to find that angle theta in degrees. I should have written it down, but I said this on another video that I did, that if you're not told specifically to use radians or degrees, just assume you want to give your answers in radians. This one, though, let me actually put it up here. Find the angle theta in degrees. All right, so we want to find the angle in degrees, and we're given this triangle where we have a right triangle, right? There's that little square there. That means that that's a right angle. Here's our angle theta over on this side. This side is a 10, and that side up there is 50. Right, so that's all we know, but that's enough information to figure out what that angle there is going to be. If we remember our definitions of our trig functions in terms of right triangles, and we pick the right trig function and do the inverse to solve for our angle. All right, so first thing, we have to pick which trig function we're going to use. Anytime we are trying to solve a triangle or solve for an angle in a triangle, and the first thing we have to do is figure out, am I going to use the sine function, the cosine function, or the tangent function? And the way I choose is I go back to SOH-CAH-TOA. All right, so if you haven't seen the videos that I did on right triangle trigonometry and the definitions of the trig functions in terms of the ratios of the sides of the triangle, you should definitely check that out where I explain what SOH-CAH-TOA actually means. So I basically have to look at, well, this is my angle. Which two sides do I know in terms of that angle? Do I know the opposite side, the adjacent side, the hypotenuse? If I know any two of those, I can use one of these trig functions to figure out what that angle is. All right, so what sides do I know? If this is my angle here, the 10 is going to be the opposite side. All right, that's the side that's opposite or across from my angle. And the 50 up here, well, that's my hypotenuse, right? Because the length of side 50 is opposite from the right angle, so 50 is the hypotenuse. Remember, the hypotenuse, the h, is always across from the right angle, the 90-degree angle. All right, so I know my opposite side and I know my hypotenuse, so I'm going to use the SOH. I'm going to use the SO here, which stands for sine is the opposite over the hypotenuse. Right, so the side of my angle is going to equal the opposite side over the hypotenuse. Right, so again, if you understand the definitions of sine, cosine, and tangent in terms of the three sides of the triangle, it's just a matter of identifying which side you know and then picking the right trig function. Right, so since I have the opposite side and the hypotenuse, and sine equals opposite over hypotenuse, I'm going to set up the equation sine of theta equals the opposite side 10 over the hypotenuse 50. And then I have to solve that equation for theta. All right, so that's the first step for solving for an angle in a triangle. Identify the sides you know, identify which trig function you need to use based on which sides you have. All right, now I'm going to simplify this a little. 10 over 50 is the same as 1/5. So I'm going to do sine of theta equals 1/5. All right, so I just take the 10 and the 50, divide them both by 10, and I get 1 over 5. All right, so sine of theta equals 1/5, and I need to solve for theta. Now, here's the mistake that students tend to make fairly often. They say, okay, sine of theta equals 1/5. Let me do sine of 1/5, and then that's going to give me my answer. Right? That's not what it says. It doesn't say sine of 1/5 equals theta. It says sine of theta equals 1/5. So anytime you are dealing with trigonometric functions and you don't know what the angle is, but you know what it's supposed to equal, like what the answer of it is going to be, you have to use the inverse sine function or the inverse trig function of whichever one you have in order to solve for the angle. Right? So if sine of theta equals 1/5, that means that theta is equal to sine inverse of 1/5. Right? So again, a key concept to understand, and it comes up in problems like this when we're trying to find angles in a triangle. It comes up if we're just given a trigonometric equation and we need to solve for theta. When you're solving for the angle, you have to use the inverse trig function. Right? Don't just type in your calculator sine of 1/5. You have to do sine inverse of 1/5 in order to solve for that angle. Right? Just like if you're solving other types of equations, like if I have x plus 4 equals 7, well, to solve for x here, I have to get rid of that plus 4, which means I do the inverse or the opposite of plus 4, which is minus 4. Right? And then I get x equals 3 because that minus 4 and plus 4 cancel each other out, right? Because they're inverses of each other. Well, here, just to kind of take it back a step, to cancel out the sine function, what I have to do is sine inverse of sine of theta equals sine inverse of 1/5, right? So I do the inverse sine function on both sides, just like over here I did the -4 on both sides. The inverse function cancels out the original, right? Just like the +4 canceled out the -4, and here I'm left with theta equals sine inverse of 1/5, right? So that's technically what we're doing here. We're doing the sine inverse on both sides to cancel out this sine function that's here to get the theta by itself. Right now, when you're solving these problems, you don't have to put the sine inverse on both sides of the equation. You can just go ahead and say, oh, if I know sine theta equals 1/5, that means that theta equals sine inverse of 1/5, right? But this is the reason why it works that way, right? So we have to do the inverse function to cancel out the sine function that's already there. And then I want my angle in degrees. So this is another important thing. You know, when you're doing trigonometry, sometimes your calculator is, or sometimes you need to use radians, sometimes you need to use degrees. So make sure your calculator is set the right way. So I just went to my mode and I changed my calculator into degree mode and then quit. And now I just type in sine inverse of 1/5. Right, and now maybe I should explain this. I'm using the calculator here. You know, for some problems we can use the unit circle to evaluate the inverse trig functions. For some we have to use the calculator. The 1/5 here, well, remember the inverse sine function. If I'm looking at the unit circle, I would be looking for the y coordinate of a terminal point. None of the y coordinates of the terminal points that I know on the unit circle are going to be 1/5. Right, 1/5 is not one of the numbers I recognize from the unit circle, and so I can't use the unit circle to evaluate this. I have to use my calculator. Right, so I do sine inverse of 1/5 and I get 11.5, let's just call it 11.5 degrees. Right, so theta is equal to 11.5 degrees. Right, now, if your calculator was in radian mode instead of degree mode, you got a different answer there and a wrong answer if we're asked specifically for degrees. Right, so you got to read the problems carefully, make sure you're giving your answer in the proper mode. And if you have to use a calculator, make sure your calculator is in the proper mode before you type this in to figure out what your angle is. All right, so again, when you're solving for an angle of a triangle, which two sides do you know as far as adjacent, opposite, hypotenuse? Which of the trig functions relates to those sides? In this case, the opposite and the hypotenuse is the sine function. Set up that, that trig ratio, sine of theta equals 10/50. Then to solve for the angle, you have to use the inverse trig function in order to get the angle. Right, so all important steps along the way to solving a problem like this. All right, I'm going to pause the recording here and then put up another example that we'll talk through. All right, next example here. A 40-foot ladder leans against a building. If the base of the ladder is 6 feet from the building, what is the angle of elevation of the ladder? All right, so for this one, first thing I'm going to do is draw a picture of this situation. All right, so I have a building. We're assuming it is perpendicular, straight up and down. We have a ladder leaning against it. The base of the ladder is 6 feet from the base of the building, and then the ladder itself is 40 feet long. And we want to know the angle of elevation of the ladder. The angle of elevation, remember, is the angle from the horizontal looking upwards. Right? So from the horizontal, from the ground looking upwards, that's our angle of elevation. That's what we're looking for here. Right? So first thing, when you're dealing with a word problem that can be modeled with a right triangle, your first step should be to draw a right triangle. Some people can read this and juggle, put a picture into their brains without actually writing it down and juggle all the numbers and know exactly how to do it. Most people, it helps to actually draw a picture so you can actually look at it and see what's going on. All right, so we've got the building, 6 feet. The base of the ladder is 6 feet from the building. The ladder is 40 feet long. Angle of elevation is that angle down in there. All right, so next thing I need to do is decide which of the three trig functions, sine, cosine, or tangent, is going to help me solve this problem. And once again, it comes back to SOH-CAH-TOA. Right, well, which sides do I have here? Right, so here's my angle theta. Well, here, the 40 feet is going to be my hypotenuse, right? Because that's across from my right angle. So the 40 feet is my hypotenuse. The building is going to be the opposite side from the angle that I'm looking for. The 6 feet along the ground here is going to be my adjacent side. Right, so I don't know the opposite side this time, but I know the adjacent side and the hypotenuse, which means I'm using the CAH here, the cosine, which is the adjacent over the hypotenuse. Right, so cosine theta equals the adjacent side over the hypotenuse. All right, so again, we have to identify which of the three trig functions we use based on which sides of the triangle we know in relation to our angle. In this case, it's the adjacent side and the hypotenuse, so I'm using cosine because that's my definition of cosine when I'm using right triangle trigonometry. All right, so again, knowing all those definitions, really important in order to do a problem like this, and knowing them well enough that you don't have to sit there for 5 minutes thinking about, well, is cosine the adjacent or is that sine, and I forget which one is which. You just need to know cosine is the adjacent of the hypotenuse. That's what I have here. I'm using cosine. All right, so if we set this up now with the numbers that we actually have, cosine of theta is the adjacent side, which is 6, over the hypotenuse, which is 40. All right, so cosine theta equals 6 over 40. All right, now in the last example that I did a few minutes ago, I simplified the fraction that we have here. It's actually not necessary to do that because when I use my calculator to do it, my calculator is just going to give me the answer. So I don't really need to simplify this fraction before I move on. Right? Once again, 6 over 40, or if I simplify that, it would be 3 over 20. But that's not one of the numbers that I know from the unit circle, which tells me I'm going to have to use my calculator here in order to solve this. Remember, cosine of theta equals 6 over 40. I don't go to my calculator and type cosine of 6 over 40. If I'm solving for the angle, I need to use the inverse of the trig function. So theta equals cosine inverse of 6 over 40. Right? And if I simplify that to 3 over 20, cosine inverse of 6 over 40 is going to be the same as the cosine inverse of 3 over 20, which is why I don't really have to simplify that fraction there. All right, so remember, just like what I showed you on that last example, technically what I'm doing is cosine inverse on this side, cosine inverse on that side, and the cosine inverse on this side cancels out the cosine, so all that's left is the theta, right? So remember, when we're solving for the angle, I've said this, I don't know, 3 or 4 times on this 12-minute video so far, but I keep saying it because it's a mistake I see students make time and time again. When you're solving for the angle, you have to use the inverse of that trig function, right? And they don't ask us for degrees here. I think the problem in the book actually said to use degrees. So I make sure my calculator is in degree mode, which it is. I do cosine inverse of 6 over 40. So cosine inverse of 6 over 40 gives me 81.37. Yep, 81.37. Right, so my theta, my angle of elevation of this ladder, is 81.4 degrees, approximately. All right, so that's a pretty steep ladder. That's a pretty steep climb if you're climbing up that ladder. 81.4 degrees, right? Because remember, 90 degrees is straight up and down, so 81.4 is almost 90, so it's pretty close to being straight up and down. So there we go. So I said in one of the earlier videos that I did that if you're not told to use degrees, that you should use radians. That's true when you're doing like purely mathematical problems. A lot of times when you're doing real life problems, we prefer to give our answers in degrees rather than radians. Because if we're actually like talking to somebody on the street, like, oh, how steep is that ladder? Oh, it's 81.4 degrees. People have a mental concept of what 81.4 degrees means. Whereas if I just kind of see what happens with this one, if I put it in radian mode and I do cosine inverse of 6 over 40, 1.42, like I want to say to somebody on the street, oh, that angle is 1.42 radians. They don't know what I'm talking about. Most people don't know what you're talking about when you give answers in radians. So if you're solving word problems and it's like a real life situation, generally in those cases we give answers for our angles in degrees. It's pretty rare that we would give answers for those types in radians. But if we're doing just a pure mathematical problem, find this angle here or solve this equation and find the angle, then generally we just use radians unless we're told otherwise. All right, so that's a couple examples of solving for angles in triangles. Remember, find the sides that you know, identify which of the trig functions fit with the SOH-CAH-TOA definitions, and then to solve for that angle, you have to use the inverse trig function to make it happen.